Alright, hello everyone. This is a first video for our online lectures. I've decided to keep these videos short and make individual videos for short topics. Obviously I haven't done this before, so these videos will get more and more refined as I make them. So let's just begin. A little recap. We got done with chapter 2 as far as I remember. We did functions, we did sequences and series. Cardinality of sets is something that I already discussed when I was discussing set theory, so that section you should check out for yourself. I would also recommend that you keep the book open on your computer, laptop, tablet, whatever you're viewing this video on, so while you view the lectures online you also have the book open so you can scroll through it and see if there's anything extra in there. I obviously just use the book and summarize whatever there is, but there might be details that are more and examples that are more illuminating for you. So yeah, we're done with chapter 2. Chapter 2, the last section of chapter 2 was matrices, which I'm going to skip. I won't be covering that in this course. So yeah, chapter 3, algorithms. What's an algorithm? An algorithm is basically a procedure, a process, a sequence of steps that you have to solve a problem. And I thought that the best way to illustrate that idea, I'm sure you've learned several different algorithms. Most of you are computer science students, so you have some idea of what an algorithm is. You must have coded it up in some particular language as well. So I'm sure most of you already know what this is, but let's just give. So I thought the best way to go forward is just to illustrate this using some example, right? So let's take a problem, the problem of basically finding the maximum element from a finite sequence of numbers, right? So you have a list of elements, you have a list of numbers in this case, and all you need to do is find the largest element in this set. Now obviously that's something that you already know how to do. You just, if I give this problem to you, you know that you just need to start from the first number and see which number is the largest, right? So you go through that list. Let's do that right now. So let's go through that list and let's see how we can do this. So 100, 10, minus 2, 45, 794. I already get a feeling that this might be the largest number, so I think I keep that in the back of my mind. I go through the rest of the list and I see no other number was bigger than 794, so this is my maximum element, right? But that's not the problem. The problem is not to find the maximum element. The real problem that we want to discuss is how do you tell a machine or a computer to do that for you? How do you write up a sequence of steps? How do you basically codify the process that you just did yourself and you make a machine do the same process for you, right? And so to do that you obviously need to write down some code, some particular, whatever language that you know, whatever language your computer speaks, if it speaks machine language, if it speaks Python, Java, whatever. And you basically need to write some procedure in that particular language to make the computer do this task for you, right? And that's basically an algorithm. So a pseudocode for an algorithm for this procedure. This is just from the book. I've just copy pasted it. And the idea is that this is not an actual code. A pseudocode is just a rough sketch of a code that doesn't follow any particular syntax. The way you convert a pseudocode into an actual code is you need to make sure that you translate each of these statements into the statements of your particular language. Now that's translation obviously depends on the language that you're using. If you're doing Python, Java, or MATLAB, you just need to know the way you will be able to write each of these steps in your specific language, right? But let's not worry about the particulars of the programming language. Let's just see what the steps are. So the first statement is basically declaring what my procedure is called. My procedure is max, and it's taking as input, so the numbers, the characters inside these parentheses are basically telling me that these are A1, A2 up till AN are the inputs for my max procedure. And this line is just the declaration of that procedure. The next line is assigning the value of A1 to the variable that I've just described as max. So in the first line, what I asked the machine to do at this point, when the machine goes through these steps, the machine at this point will say the first number of my list. So in case this was my list, A1, A2, A3, A4 up until AN, the machine will say that the max is A1, which is basically 100. Then it will start this for loop. I hope you're all familiar with for loops. If you're not, I will go into the details if anyone requires me to. But a for loop basically sets a variable I, and it goes through each of the values of I and processes each of the inputs for each value of I. So now the value of I is from 2 to n. I evaluate this step. If max is less than AI, then set the max equals to AI. So basically what the machine is doing is, when it starts this for loop, the value of I is 2. My value of max is A1, which is 100. And now the statement when the machine first goes into this for loop is basically max is less than AI. So it decides whether this is true or false. Now obviously max was A1, which was 100. So the value of max is 100. AI in this case, because I is equals to 2, so AI is equals to A2. So this is A2, this is max, and this if statement just compares the value of 110, and it decides that no, my A1 is not less than A2, and therefore I will just consider this to be, and I will not process this next step. That is, I won't assign the value of A2 to max. So this statement is false. I'm not going to process this, and I'm going to move to the next value of I. Let's see what happens when I goes to the next value. So I is from 2 to n. In this case, my n will go from 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 values. My for loop will run from I equals to 2 to I equals to 9. And anytime it encounters a value which is greater than the current value of max, it will just shift that value. So I would encourage you all to run this procedure into your head, assume that you're a machine following these steps, and see if you can use algorithm 1 to find the max value in this list. And I'm sure you all can do that. Right, so that's just a basic example of an algorithm, and that's just what an algorithm is. It's just a sequence of steps designed to solve some particular problem. Now let's modify the problem a bit. Let's suppose I change the list of inputs. So now my inputs contain 100, minus 10, 30 plus 50, 794, 111. In this case, obviously there's a problem. If I follow the algorithm that I've just declared, my machine has an issue with this element, which is that it doesn't have a value yet. It's a statement, it's an operation, so I need to modify my algorithm a bit. My machine would first need to evaluate this value before it can decide whether max is less than A1, A2, whatever, right? So in this case, my algorithm needs to be modified so that I evaluate each of the values first before I decide which value is the maximum. Another problem can arise if you have something different in your list, something unexpected. So for example, 100 minus 10, 1 billion. Now, this is a different type of input. If you give it as is to a computer, you would need to translate it somehow, right? And this is a discussion in which types comes in. For example, the next example in which I've added x plus y. Now this statement is obviously meaningless if there's no value of x and no value of y in my machine stored somewhere in my storage. And similarly, this ridiculous element over here. So the algorithm will run into an issue because it won't know how to evaluate this max less than AI for this particular element. And so what you would need to take care of as computer scientists or somebody writing this code is make sure that each of these elements is of the same type. It's an integer, it's a floating point integer, it's a double, whatever different types you want to deal with, but they all should be of the single type so that you can compare them somehow. And so you should think about that these problems will arise when you try to solve a particular problem using an algorithm. Right. So what kind of different properties can an algorithm have? An algorithm has an input, has an output, which we just saw. I'll just go through these terms and we'll discuss them from the point of view of the example that we just did, right? So input and output. Definiteness, which is basically each and every step should be defined precisely. There should be no ambiguity. Your machine should not have any issues following all the steps that you outlined in your algorithm. The next thing is obviously correctness. Your algorithm should be correct. It should give you the desired output. So if you've designed an algorithm for a maximum value from a list, it should obviously, anytime you give it a list of numbers, it should always give you the correct maximum. If it fails to give you the correct maximum, then obviously it's not a correct algorithm and you need to correct it somehow. It should also have the property of finiteness, which is basically it should find the max element in a finite number of steps. So if your algorithm keeps on going, if there are infinitely many steps to your algorithm, then it won't stop and it won't give you an output in finite time. Effectiveness is a bit of a term that's a hand-wavy term. It doesn't really have a precise definition, but it doesn't really have a precise meaning as well. But the idea is it's a bit of a combination of the ideas of accuracy and speed. So consider this. Let's say you have two algorithms. One algorithm gives you the correct answer in, let's say, 30 days. And let's say the second algorithm gives you an incorrect answer, but it gives you in about, let's say, 5 minutes. Now, which of these algorithms is more effective? If you care about accuracy, then of course the first algorithm is more effective. But if you're okay with an approximate answer, for example, if for the max of an element it gave you something really close to the max of an element and you don't really want your algorithm to be as accurate as possible and you might want it to be as fast as possible, then for you that algorithm will be more effective. So it's again a bit of a context. It depends on context, the kind of problem that you're solving, and so on and so forth. And finally, your algorithm should be a general algorithm. So what that means is it should be able to solve any problem of the intended class. So for example, if I have designed an algorithm to find the maximum element from a list, it should find a maximum from, let's say, integers. If I intended to find maximum elements from the real numbers, then it should also work from a list of real numbers. If I give it an irrational number, it shouldn't have a problem. But the idea of the intended class is important, which means if I have designed an algorithm that just checks an integer that just checks a list of integer, and I did not intend it to work for real numbers, then you shouldn't expect it to work for real numbers. Which means basically you can't say that my algorithm isn't general enough if I have claimed that it only works for integers. Of course, it should work for any list of integers, but it doesn't need to work for a list that contains elements other than a list of integers. Right, and yeah, so that's about it for this section. I will upload another video for the next section. Next, we'll be discussing some algorithms, specific algorithms, basically searching, sorting, and string matching, and some other examples.